Welcome to a new episode in the Multiverse video series. Today we're going to introduce cloudml, a package that can help you train deep learning models with ease in Google Cloud Compute. So what is Google Cloud Compute? You might have seen from previous videos in which we introduce Kubernetes and things like that. Google Cloud Compute is simply Google's cloud infrastructure, similar to AWS or Windows Azure, and why not, that allows you to borrow resources from Google to train models or to just run computation. So for this particular video, what we're going to do is we're going to train a model, and we're going to explain the specifics of what Google Cloud is and how to do the setup while the model is training, since this might take a few minutes. The machine that we're currently using is a very low in specifications machine. It's just Google. It's just an AWS machine that we actually used on a previous video, and it doesn't have a lot of interesting, performance characteristics. It just has one CPU and 2 GB of RAM, and it obviously doesn't have a GPU. So this is an interesting use case for Google Cloud Compute, where you may have an expensive deep learning model that you want to train, or in general, you could actually even use these for non-deep learning models. Although, the instance types that Google supports are optimized for GPUs. But in general, even if you have a very slow machine like this one, you can take advantage of Google Cloud by borrowing the resources, train the model, and then collecting the results back in your local computer. So what we're going to do before we explain how to install the cloudml package and go into the details, we're just going to start a run training something. And then by the end of the video, we will actually look at the results of this particular run. Right, so go ahead with me and just, we'll explain this in a second. So what we've done right now is basically taking an R script, and we're sending it to Google Cloud to train a model. So what exactly is going on? Well, as I mentioned, we're using Google Cloud Compute to perform, in this case, model training. If you're setting up a new account, one of the first things that you need to do is sign up with Google Cloud Platform. That will be the first step. And then as a second step, what you want to enable is what used to be previously called Google cloudml. It got renamed to Google AI Platform. And I don't remember exactly when this got renamed, and I think it might have been this year, but it doesn't matter. The interface is still pretty similar, and it's pretty much that. It's cloudml with additional new features and improvements. Right, so the first thing that you want to do is, when you arrive to this page, is you would want to go to Jobs. And what you're going to see on the Jobs pane in general when you arrive for the first time to Google's cloud platform is that you need to enable this API. So again, you need to sign up and then enable this particular service, which is the Google AI Platform. And once you have it enabled, you're pretty much good to go from a setup perspective on Google Cloud. One of the first things that you would have to do, and we're going to start here in a new R session. So what you would do with your RStudio session to start using Google Cloud Compute would be to first, launch RStudio, and then you would want to create a new project. This is particularly important for using the cloudml package, because a package gives you a context of what are the dependencies that you need in order to execute this in Google Cloud. You can also just trigger it with a plain R script, but it gets messy. So for those of you that have heard about Packrat, basically cloudml uses Packrat, and Packrat has the capability of detecting all your dependencies, but it gets much easier if you create your a new project, which is usually what I recommend doing. So create a new project. You can name it whatever you want. So we're going to name it cloudml2, and we'll create a package. Sorry, not a package, the project. Right. So we have a new project, and then what do we do next? Well, in this particular case, what you want to do is first install the cloudml package. So you would do install packages cloudml, and that would install the cloudml package. The next step, what you want to do is you want to say cloudml install. What this function is going to do is basically install for you the Google Cloud Developer Kit. And this looks like this. It's basically just installer. You need to basically click next and accept the default settings. And what this tool does, the Google Cloud SDK, basically allows your computer to communicate with Google's cloud platform and execute commands and why not, which is basically what we're doing through the CloudML package. All right, so I already did for us. We don't need to repeat the steps. When it's done, what you want to run is Google Cloud Init. So Google Cloud Init is basically gonna launch the initializer script from the Google Cloud SDK. And again, in this particular step, you can mostly just accept the default settings. The only setting worth double checking perhaps is when you get prompted to choose data center region or zone, as Google calls them. You can basically choose, to use like somewhere in the US or Europe, Asia, or why not, and within the US you can pick different zones. But yeah, that's pretty much it. So we're not gonna do this because I already execute this for us. But basically, you get to just get prompted some configuration settings, and that's pretty much it. So in this particular example, I'm not gonna run a deep learning modeling training session. I'm gonna do something a bit simpler. So in this particular case, since I mentioned that Google Cloud is optimized for executing code in large machines, in GPU machines, and in TPUs, which are Google's own hardware for optimizing deep learning models. But the CloudML package itself is not restricted to deep learning. In fact, it doesn't really have any dependencies to TensorFlow or Keras. It's just a generic package that allows you to push our scripts to be trained in Google Cloud Compute. So you can basically use anything. And in this particular example, I just went to the xgboost R tutorial just by searching xgboost R. And you can take a look at xgboost. You can install xgboost, which is what I did on this particular machine. And then you can basically just copy paste the code for this particular tutorial, which is what we're gonna do. So again, xgboost is a pretty popular machine learning library. It seems I read somewhere that they were thinking of adding GPU support. So maybe this is something that is worth for some of you to consider. I honestly haven't tried it, and I don't know how great it would work with Google Cloud. I honestly don't know the state of the art with like R integration and why not. But again, if this is something that you're interested in, maybe it's worth looking further into this. I'm just gonna focus on the CloudML package and how to run this in the Google Cloud Compute Engine through CloudML. So what we want to do is we want to copy the code. We copy basically the XGBoost training step, which is going to be a really fast one for this particular model. Let's see, we're missing to include XGBoost. And then we can rerun that. And again, this is a very simple example. So, it doesn't really give merit to training models in Google Cloud because it's just a toy example and it's pretty simple. So yeah, we have this particular model which is trained. So what you would do is in order to train this model in Google Cloud, you would have to create a new file. So create a new R script, and then you basically want to use the code that you were using right before, except that you want to also include the CloudML. Actually, yeah, you don't even need to, I'm pretty sure you don't even need to include the cloudml library. But you do need to include you do need to include the xgboost library. So we can do that, and then we can just basically train the model. Copy that particular line. And there's one more step to do. So if we just were to ask Google Cloud to run this, basically what would happen is that the model would get trained, it gets trained, and then it's done, right? The training happens, you get the results back, which is basically any logs or any information that you've had previously, that we have, that the package has set up for you. But the model is not gonna be there when using generic models. If you use TensorFlow and Keras and TF-Run, it's a different story. But this particular example, you also need to save the model. So what we want to do is we want to save this particular model, and we can just call it bst parse.rds. So by default, whenever a job finishes in cloudml, all the files that got produced as part of that run are gonna get fetched back to you. So this would guarantee that just saving this file, when you get it back in your job completion results, you would be able to reload the model. So that's pretty much it. So you want to save this particular model. You can just call it whatever you want. We usually call it just train.r. And then what you want to do is you want to say cloudml train, and then train.r. That's pretty much it. Then your script will gonna go up to Google Cloud, get executed, and the results will get retrieved. So what do you do once you submit a job? Well, first of all, you need to give it a few seconds to actually have the cloudml package and packrat to prepare the bundle that is going to be used on Google Cloud to compute. This usually takes like about 30 seconds or why not. And then you will get prompted an option to either, just leave these unattended and, not collect the results. Or as you can see here, you can also choose an option to monitor the results. So we're going to say, yes, we want to monitor the results inside RStudio, which by default uses the terminal. So it can give you like a good sense of, if what exactly is going on Google Cloud and what the progress is going for this particular job. What I like doing instead is looking at the jobs panel. And once you go to the jobs panel, you should see your basically job submitted. So in this case, this is the job that we just submitted. And this is the job that was completed in the previous code that we executed at the beginning of the video. So as you can see, there is a penalty currently from executing anything on Google Cloud. So and this is about right. There's usually about 7 minutes, 8 minutes. You can reduce this a little bit by using a larger instance. Right now we're using the bare minimum small instance. So things that happen under the covers is like packages need to get built, they need to get cached. CloudML is smart enough to cache some of the packages, and why not? But still, there is a penalty for transferring all your model, like setting up the environment and then collecting the results. So it really doesn't make sense to use Google Cloud for small models. If something takes less than 8 minutes, it's probably not worth using Google Cloud in this particular, with this particular package, CloudML. But if you have like a particular model that is actually pretty heavy and is taking, like an hour or so, and why not? And especially when you get to deep learning and you actually need to use GPUs or TPUs, then it becomes a no-brainer to pick a GPU or a TPU from Google Cloud using this package. All right, so this particular job got created. So let's just look at the results. So I'm gonna switch back to the previous instance of RStudio. And what we can see here is that the job finished. and the results got collected. So this is a new directory that it just got created after the job finished, which is called runs, and it has the particular run that you're using. So what we can do here now would be just to say read the results. So we can say read RDS, and then we can just look at that particular runs folder, and then the cloudml particular instance, and then the RDS model that we save. And when we read this particular model, you can see that we get the exact. Actually, I don't know if they're exact same results. Let's just take a look at that. But we basically run the exact same code, 46, 52.2, 46, 5, yeah, 6 to 5 to 2. So yeah, we're actually getting the same results. I mean, this depends obviously on the package. It's running on a different machine. So as long as it's a deterministic package, you should get the exact same values. In deep learning, usually you might not, because a lot of random initialization happens, usually in deep learning models. But the code that is being run is exactly the same. And we know that is the exact same code mostly because we're using packrat to make sure that the package versions that you're using and everything works properly. So in general, this concludes the video. This gives you like a great overview of how to use cloudml in R and how to set up your Google Cloud Computing instances to make use of Google Cloud from R. However, I do need to mention a few things. There was a recent release of the Google SDK, and the first time that I run this, I actually, as you can see here, and this was today, it was from a brand new account that I haven't used, I hit a few errors, and it took me a little bit of time to troubleshoot what was going on. So the good news is that you probably don't need to worry about this. We're making changes to the cloudml package, and by the time you use cloudml, like you probably won't hit these issues. But it's also a good experience to present in this video to figure out how to troubleshoot issues, and like if you were to hit similar things, you would know how to troubleshoot them. All right, so the first error that I hit was actually just when I was pushing the particular model to cloudml. So I was running this and I was hitting an error. The first thing to do when you're troubleshooting in general R packages, it's a good recommendation just to go to the actual repo. In this case, is the RStudio cloudml website, which you can then navigate to issues and see if someone else has already hit this particular problem. So as you can see here, someone kindly enough already opened a GitHub issue for the particular issue that I was hitting. In this case is list object has no attribute get, which was exactly what I was hitting. And usually if you read at what are the, like what is the discussion on the particular issue, you can see the workarounds, right? And in this case, what we figure out is that the new SDK might have broken the cloudml package, so you can revert to a previous version by executing this command in the terminal. So all you have to do would be to run this. And that's pretty much it. The other issue that I hit was actually when I was training the model. And when I was training the model, we can see some of the errors here. And yeah, the particular error that we were hitting here, you can look at in the logs, which is pretty useful to look at whenever there's an error happening. So you can click the logs and then you can kind of like scroll and try to figure out what is why it's breaking. So the second error that I hit was error in read RDS, cloudml deploy.rds. And if another thing to try out, and I won't get into too many details, but this is an issue that was previously open as well, and it's already fixed in the cloudml package. However, we haven't pushed a new version of cloudml to CRAN. So by default, the version that you have installed would be the CRAN version, which is currently 0.6.0. So what you would want to do in this case, in this particular case, which again, it's likely that you won't hit since a new release to CRAN would be available, But if there's fixes that you need to take from particular package authors that are not available in CranJet, what you could do is you can say install GitHub using the remotes package. And in this particular case, all I had to do was say rstudio/cloudml. So this would install basically the newest version available on under development in the master branch for the cloudml package, and this would solve the second problem that I hit. So so if we go back here, subsequent jobs would basically just succeed after this. In this case, even the job that we just triggered succeeded. If you need more information, you should take a look at tensorflow.rstudio.com. The CloudML documentation is under Tools, and then you would have to navigate to CloudML. One interesting thing to highlight here, apart from this website being a great resource, you might want to take a look at the CloudML pricing hyperlink that we have. And in this particular website, basically what you can see is what is the cost associated from using Google Cloud. I'm pretty sure that we're using the standard instance while we're executing CloudML by default, which it's a pretty small instance. Actually, we could do Google Cloud standard 1, and we should be able to see here what is the machine type that it's available. Is it available here? Yeah, well, standard 2. I guess standard 1 is not even here. But yes, standard 1 is a really small machine, and this also explains why the training time was also pretty slow. If you use a decent machine, the setup usually gets reduced in time as well. But so by default, it's a very small machine. It doesn't help that much to speed up training. So if you wanted to use a different type of instance, you would have to change the master type. So for instance, you can take a look at a couple options that you can choose if you look at the master type. When we're actually when you take a look at the documentation, and the docs point you back to just this particular website that we're looking at, which is just a list of all the types that are available in this particular region. All right, so as you can see, there's multiple types of instance. The interesting ones are the ones that contain GPUs when using deep learning, or if you're training a particular model with a lot that requires high memory, and why not? You could also take advantage of high memory instances. In this particular case, I believe the last number on the instance ID is the number of CPUs. So you could get potentially like 80 CPUs to train a model, or why not? Or you could use a machine with 80 gigabytes, or if you keep scrolling down, we should be able to see the GPUs. Let's see, is still CPU, memory, standard, micro. Actually, the GPUs and compute engine. So I guess you need to go to a different just website to take a look at the actual compute instances when using GPU, which would be these cases, right? So NVIDIA Tesla T4, why not? And the TPUs might be also here, or maybe they're on a different, pricing might be on a different site as well. But you'll figure that out. You'll have to choose which is the instance type that is most useful to you, and then basically you can do a quick calculation figuring out what's the cost, right? In this case, I believe this is the cost per hour for a standard machine type. So it's 20 cents. I'm not even using, in the runs that I'm using here, I'm not even using like a full hour. So it's really a small fraction of cost to play around with this. However, as you use more interesting instance types that have more capabilities, your cost can go up, and it's just worth being aware that this is not free. All right, well, thank you so much for listening to this video. I hope it was useful, and apart from getting you started with CloudML, I'm hoping that the troubleshooting section gives you some sense of how to do and what problems you should focus on when things don't go the right way. So thanks again for listening.